This video shows how children develop the ability to perform basic written multiplication. Here, see how the coins and the hundred square are used to show the pattern made by the 5 times table visually. To be able to multiply using tens numbers, the children have to notice the link between, for example, 5 times 3 and 50 times 3. Similarly, when they can grasp that by knowing 7 times 5 is 35, they also know that 70 times 5 is 350, they can calculate with bigger numbers. Children learn to multiply tens and units numbers, like 18, by partitioning them, here, into 10 and 8. Dean's pieces are used to show 18 times 3, here, in a grid. Children might learn to write partition multiplications informally, like this. Ultimately, they'll learn to lay them out in a grid, as shown here to calculate 38 times 7. The parts of the numbers that have been multiplied, 210 and 56, are added. Let's have a look at that method in action. To do 24 times 6, the first thing I've got to do is partition the 24 into 20 and 4, multiplying both parts by the 6. To do 20 times 6, I need to do 2 times 6 is 12, adjust it to make it 120. 6 fours are 24, and then when I add the numbers up, I need to be careful as to the columns that I lay them out into, and then of course it's just a simple case of adding them to get to 144. The grid method's great for showing children how multiplication works, and you can see it here for 342 times 7. The only problem is, it's quite a long-winded process. There are many steps. A more efficient method is using short multiplication. It's a very similar process. First of all, 7 times 2 is 14. I put the 4 in the units column, carry the 1. 7 fours are 28, add the 1 to the 8, and that makes 9. And then 7 threes are 21, so add the 1 to the 2 makes 3, and put the 2 down, and then of course it's just a case of carrying the 2 there, 2,394. Just a slightly more efficient process. Children need to learn to multiply and divide by 10, 100 and 1,000. One way they can think about this is by adding or taking away zeros. So for example, 65 times 10 equals 650. Of course we don't teach this method because when it comes to using decimals, like this example, it just doesn't work. We need to talk about the digits moving columns. We'd model the process by showing clearly the value of each digit and the column that it's in. So for example, 34 times by 10, the 3 and the 4 move like that, so it's 3 hundreds, 4 tens, and we need a place holding 0 to show that's 340. For 650 divided by 100, children will know that the digits move 1, 2 places, giving us 6.5. And finally, 4.16 times 100, children will know to move the digits 1, 2 places, giving us 416. Children will then be given multiplication questions in a range of different contexts. For example, scaling up, ratio, or even looking for a number of combinations. All different contexts, all looking at multiplication. Rather than extending children by giving them more difficult questions, we would see how divergently they can apply their current level of understanding. For example, 16 times 9. They'd probably start by doing 10 times 9, 6 times 9, and adding. Well, could they find a different way to do that? For example, 16 times 10 and taking away is 16. Or even partitioning the 9 into 5 and 4. They might do 8 times 9 and then double. How many different ways can they see 16 times 9? Similarly, have a look at these examples here. We might ask children to match them up. Which ones are 7 times 4, which ones are 6 times 4, and how do they know? In this way, we challenge children to think deeply.